Alrighty, so let's get started on this review. Gaming system is sold to stores at a wholesale price of $97. Popular Store sells it for $197. So we want to know what is the markup. Your markup is going to be the difference in the price that you sell it for versus the price you got it. All right. Chances are the price you got it was at a wholesale price, which is that $97 right there. So when we go ahead and just simple calculations, 179.99 minus $97. We type that into the calculator and we end up with type that in wrong. You end up with $82.99. That's the markup. So go ahead and type that in and you win. Moving on to question number 2. Question number 2 says, what is the equilibrium price? The equilibrium is where demand and supply meet right here at this point here. So at this point, the price is $11.49. Next question, what will happen if the price is set at $7.99? And what will be low supply? What will be low, supply or demand? Should have been a question mark there. So right here at $7.99, the supply is here and demand is up here. So supply is low. Supply is too low for the demand. Okay. How many game controllers are demanded at a price of $7.99? We can see it right here at 200. And, well, I should say demanded. My bad. So that's up here. 1,000 is demanded. And right here it says how many game controllers are supplied. So looking at our supply, 250 is supplied. What will happen if the price is set at $12.99? What will be low, supply or demand? So at $12.99, which is going to be in this area, we'll mark this as demand, a little lower, supply, a little higher. I don't know why I put an L there, but supply is going to be higher. So demand is lower here. Less people are going to demand a product when it's at a higher price. Moving on. And now we go to number 3. Number 3 here says a widget is sold to stores at a wholesale price of $28. If the store has a $10 markup, what is the retail price? That's real simple and easy. That's going to be $28 plus the $10 markup, which is $38. It's going to be $38. And now it says here, find the percent increase of the markup to the nearest percent. So the markup is going to be based on, the original price. So this thing got marked up. The difference between $38 and $28 is going to be the $10. And we're going to divide that by the original price that we got it for, which is that wholesale price, which is 28. So 10 divided by 28 times 2. Oh, wait, not times 2, times 100. You end up with 35.71428571%, aka 36%. All right. That's how that works. Again, $10 represents the difference in price sold. That's going to be the difference in the price sold. And $28 is the OG, the original purchasing price. At this point, it's the wholesale price here. So the difference divided by the OG is going to give you the percent change. All right. And we move on. Let's go here to our demand function. The demand function for a certain product is Q equals negative 300P plus 10,000. The fixed expense is 50,000. The variable expenses is $2 per item. Express the expense function in terms of Q. So the expense function in terms of Q is going to have your variable cost right here and your fixed cost here. So what does that look like? That looks like Y equals 2Q plus 50,000. Well, 500,000, my bad, 500,000. And now for B, it says use substitution for the demand function and for Q to express the expense function in terms of P, which is price. So what we'll do, we'll substitute Q right here. Q is actually equal to negative 300P plus 10,000. All right, so that goes there. Still, what's in front of Q? This 2. What's behind Q? This plus 500,000. And so we get our calculator and we start distributing. That's going to be negative 600P plus 20,000. And then we got to add the 500,000 on the back end. So we'll combine these like terms and get negative 600P plus 520,000. So this is E in terms of P. E in terms of P. And I got Y right here. This should be E in terms of Q. So make sure you got negative 600 typed in for your first blank and 520,000 typed in for your second blank. And we move on. Express the revenue equation in terms of price, given the demand function is Q equals 900P plus 120,000. Hint, R equals P times Q. So because R equals P times Q, we plug in Q and we end up with Q being equal to negative 900P plus 120,000. All we're going to do is distribute P, and we end up with negative 900P squared plus 120,000 P for our revenue. So that goes into our first two blanks right there. Negative 900 and then 120,000. What is the revenue if the product is set at $5? If I plug in 5 right here and 5 right here, type it into the calculator, we'll get our answer. So let me go ahead and get the type in. Negative 900. That's going to be 5 squared plus 1, 2, 0, 0, 0, 0, 5. The revenue is going to be 577,500. What price would lead the highest revenue? I would definitely graph at this point. We would use Desmos graphing to get this. Or we can use the function negative b divided by 2a to find that price. So in this situation, our b value would be 120,000. And we'll divide that by 2 times negative 900. If I type this into the calculator, negative, clear. Let's go fraction button. 1, 2, 0, 0, 0, 0. Close that parenthesis. 2 times negative 900. Again, when we type this into the calculator, we end up with $66. Typing that into the calculator, we get $66.67. And we move on. What is the max revenue at this point? The max revenue at this point, meaning we just plug in $66.67 right here and right here. We go into the calculator, negative 966.67 squared plus 120,000,066.67. You end up with, strangely, $399,999.99, which we would eventually round to $400,000. Okay, $400,000 in max revenue. Oh no, matter of fact, I think I'm missing a number here. It has 1, 2, 3, 4, 5, 6 nines. 1, 2, 3, 4, 5. All right, so yeah, I need to erase that. So a little bit higher. So 1, 2, 3, 4, 5, 6 nines. So that ends up being $3,999,999.99, aka $4 million. There we go. $4 million to correct that, all right? Make sure you got that in for your last bit. So right now, the answers that we have here, right there, everything boxed are considered answer inputs. And we move on to the next problem. Let's go to number 6. Number 6, they want us to write a profit function. Profit is going to be R minus E, and E has to be in terms of P. So right now we got E in terms of P here, and we have R in terms of P right here as well. We just need to combine these two. So one thing that I like to do when we're doing this by hand, make sure E is negative. If E is negative, that makes this value positive. Then it makes this value right here negative. And then we're just going to combine like terms. So I don't see any other P squared. So let's go ahead and put 600 here. For my single P's, I got a positive 25,000 and a positive 3,000. So if I put those two together, I end up with 28,000. And last but not least, this is my constant. No other constants down here, so minus sign is already there. 250,000. Easy money. Now from here, we would go into Desmos to graph this to get the max profit and also those break-even points. I will let you guys do that in Desmos. Again, this is going to be your profit function. P equals 600 P squared plus 28,000 P minus 250,000. If you graph that, you'll be able to find your max price and profit. Down here, if you graph your R function and your E function, they'll show you the break-even points where revenue and expense cross perfectly. It should have 2 points when you graph them. And we move on to the next one. For our next problem right here. Right here, we're looking at where we're going to find our max profit. It says determine the following based on the given information in the graph above. Yes, not all lines are able, but you can determine missing values based on the values that are given. Okay, so at what price will a maximum be reached? At what price will a maximum be reached? We got to know the scale first. So I'm looking at this line here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines that go all the way to 200. So if we do 200 divided by 10, each one of these should be equal to 20. So 20, 40, 60, 80, 100, 120, 140, so on and so forth. You get it. And we build it all the way up to 200. That leaves us with max profit right there. This guy right here is going to be my max profit, and that's going to happen at $60. Now, what is the value there? Again, we got to determine the scale going this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I take this and I divide it by 10. I end up with what is that, 10,000. So 10K, 20K, 30K, 40K, 50K, 60K, 70K. Y'all see it right there. 80K, 90K, 100,000. So answer right here is going to be 60 and 70K, which is 70,000. And our break-even points are going to be right here. The first one being at 40 and 300,000. The next one being at 80 and what is that, 20,000. Easy money. And that one's in the bag. That was just some basic partition in the segment right there. And we move on to the next. And is this the last problem? Yeah, this is the last problem. Right here it says, what was the equilibrium price before the demand shift? So the demand shift, this is going to be our first demand, and this is the second demand. As you can see, D1, D2. The demand shift, it decreases. It goes down. All right? And you can get that based on what's happening here. Demand dropped to the new demand curve right here. The movement of the curve is called a shift. This right here is a shift. All right, so what was the equilibrium price before the demand shift? Equilibrium price is right here at $3. What was the equilibrium quantity before the demand shift? Right here, the quantity was 100,000. Next one, what is the equilibrium price after demand shift? So we're down here on D2. Demand shift goes down to $2.50. What is the quantity on the demand for the second demand shift? The quantity was 10,000. You don't need the comma, but whatever. And last but not least, what was the percent decrease in sales, in the sales price for the product, round to the nearest whole percentage? Difference divided by original. Okay, so the difference between $3 and $2.50 is 50 cents. That is our difference, okay? And we're going to divide it by the original, which is $3. $3 was the original price. So when we divide there, 0.50 divided by 3, you end up with 16.6 repeating, which is rounded to 17%. All right. Easy money, easy money. Again, good luck on y'all work today. Finish review, get a nice little A, and hopefully you get started on this test. We want to have this test finished soon, very soon. Definitely want to have it finished by Wednesday. That will be great. Signing out.